A relation R subset of A cross A is antisymmetric if this statement is true. As an example, let's consider the relation R subset of A cross A, where A is the set containing the numbers 1, 2, and 3. And let's say that R is the relation subset of A cross A defined by this graph. Now the question is this relation defined by this graph antisymmetric? And to decide, I'm going to make a table very similar to the ones that I did in previous videos. So this will be our statements, P implies Q. This will be all of the statements that are defined when you consider the for all x, y in A in the blue underlined statement above. And over here we'll decide if those statements are true or false. Remember, if they're all true, then this relation satisfies the statement underlined in blue and therefore is antisymmetric. All right, so let's first just look at the P part. P, and in P implies Q. So P is x is not equal to y. So now what I'm going to look for is all of the vertices that are 1, 2, or 3 that are not equal. So we have, for P, we have 1 does not equal 2, 1 does not equal 3, and 2 does not equal 3. And that's all we have. Now I know what you're saying. You're saying, well, you did something different in the previous videos. You also had something, you would have 2 not equal to 1, 3 not equal to 1, and 3 not equal to 2. But let me show you why we don't have to consider those other possibilities. So 1 not equal to 2, right? That's the same as 2 not equal to 1. And look what arises. When 1 is not equal to 2, the Q part is 1 is not related to 2, or 2 is not related to 1. And down here we have 2 is not related to 1, or 1 is not related to 2. Now, 1 not related to 2 or 2 not related to 1 is equivalent. And you could show this with a truth table. That's equivalent to 2 not related to 1 or 1 not related to 2. So because of that equivalence, I don't really need to write all the cases where 2 is not equal to 1, 3 is not equal to 1, and 3 is not equal to 2. All right, this gives 1 is not related to 3, or 3 is not related to 1. And the Q part here is 2 is not related to 3, or 3 is not related to 2. All right, so now looking at our graph, right, this first arrow here, this tells us, this arrow from 1 to 2, this tells us that 1 are 2. And the arrow from 3 to 2, this one here, this tells us that 3 are 2. Okay. Now, because we don't have that, right, if we had an arrow there, what would that say? That would say that 2 is related to 3. And if we had an arrow there, that would tell us that 2 is related to 1. But there is no arrow there, so we don't have that, and we don't have that. All right, so let's go down the line now. So let's first start with this first row here. Is 1 not equal to 2 true? Yes, it is. So this is true here. Okay. Now 1 not related to 2, right? We know from this one here, right, that 1 R2 is the one that is true. So 1 not R2, that's going to be false. Now 2 not R1, we have that, right? We know that's true, so that's true. Okay. Now moving on to this one here. 1 not equal to 3, well, we know that's true. 1 not related to 3, well, let's see, where's that? Oh, we didn't cover that one yet, did we? Oh, let's look at that. Well, we don't have an arrow right here, right? If there was an arrow right there, that would say that 1 are 3. But we don't have an arrow there, so we have that. Okay? Similarly, if we had an arrow like that, that would tell us 3 are 1. But we don't have an arrow there, right? So we know that 3 is not related to 1. All right. Okay, so 1 not related to 3, we know that's true. And 3 not related to 1, we know that's true as well. Okay. Now moving down to the next row, 2 is not equal to 3. Well, we know that's true. We know 2 is not equal to 3. Now 2 not related to 3, that's right there. So that's true. And 3 not related to 2, well, that's false. That's false because we know 3 is actually related to 2. Okay, now let's remember our definition of P implies Q. P, Q, P implies Q. All right, now let's see here. Now I'll put the overall value. Okay, so false or true together, right? False or true is true. True. True or true is true. True or false is true. So you see, what do we always have? We always have, I'll make these green so it's easier to see. We have true implies true. True implies true. True implies true. True implies true is always true. So we have true, true, true. So because all of the conditional statements that the underlined blue statement defines are true, then we know that P implies Q is true for all xy in A. So therefore, this shows us that, in fact, this relation is anti-symmetric. Now there's one more thing I'd like to show you here. Notice that this graph is not symmetric, right? To be symmetric, we would need that and we would need that, but we don't have those here. So this one is not symmetric. So here's an example of a relation that is antisymmetric, but it's not symmetric. But don't think this is always the case. These are not opposites of each other. Antisymmetric and symmetric are not opposites of each other. And I will show you an example of this now. All right, in this one, let's say we'll use the same set A, 1, 2, 3, and the graph and this graph, or the relation defined by this graph. Now, this is not symmetric, right? Because to be symmetric, we would have to also have that. So it's not symmetric. Now remember our definition of antisymmetric. Oops. That was underlined in blue above. Now, this is a for all, right? This is a for all. Remember, how do you disprove a for all? You find a counterexample. So let me find a counterexample to this. And that counterexample resides right here. Two does not equal 3. So this statement is false. Let's see why that's false. Remember that this arrow from 3 to 2, this tells us 3 are 2. And the arrow from 2 to 3 tells us that 2 are 3. So that tells us that this statement here, right, is equivalent to, right, because we know 2R3 is true, so not 2R3 is going to be false. And we know that 3R2 is true, so not 3R2 is false. So this is false. So what we have here is we have false and true. True implies false is false. So because of this counterexample, we see that this graph is not symmetric and it is not antisymmetric. Now let me show you one more example. This one will be rather quick. Now let's say that our set A has just the numbers 1 and 2 in it. And we have this graph. This graph, the relation defined by this graph is antisymmetric. This is because 1 does not equal 2 is true, and the OR statement 1 is not related to 2 or 2 is not related to 1 is also true. Right? It's true that 1 is not related to 2. Okay, we've got that. How about 1 is not related to 2? Well, there's no arrow or directed edge from 1 to 2. So we know that's true. And there's no directed edge from 2 to 1, so we know that's true. True or true overall is true. And that's true. True implies true is true. So it is antisymmetric. This graph is also symmetric. Now, why is that? Remember the definition of symmetric. Well, since there's no edges, we know that 1 is not related to 2. And also we know that 2 is not related to 1. So XRY is always false. This is always false. And anytime you start with a false, you know the overall if-then statement is true. So it is symmetric. So what I'm trying to show you here in these three examples is that the common misconception that students make is wrong. It is false. So it is not true. It is not true that antisymmetric and symmetric are opposites. This is not true. And we can see that that's not true because here we have three examples. We have an example where we have an example of a graph that is both antisymmetric and symmetric. We have an example of a graph that is not symmetric and not antisymmetric. And we have an example of a graph where the relation is antisymmetric and not symmetric. So we know from these examples that they are simply not opposites of each other.